Okay, I'm Tom Briggs and I'm from Bletchley Park. Still feels weird saying that because up until Christmas I was a maths teacher in Northamptonshire. I still feel a bit like a maths teacher now because I go around the country with the Enigma machine and I do sessions on codes and ciphers, and I try and sort of fit in lots of maths. The title is shoehorning codes and ciphers into your lessons, but I really don't think that's the case. I think it's utilising the maths learning and excitement of codes and ciphers into your lessons. That doesn't make sense, so I'll cross the two out. Okay, I just want to give you some ideas today that might fit into the classroom and help you put some context into some of the things you have to learn. Because I know sometimes that can be difficult. So today you will, learning objectives, see? See how code breaking can be used to inject intrigue and relevance into activities. Suddenly have some great ideas that you can share with everyone, especially me. Okay, I've given you this in your packs, and some of you have had a go at it. Has anyone come up with any ideas so far in the few seconds I've given you to start off?
The first word, hello.
What was that, sorry?
First word, hello.
The first word's hello. How do you know?
It's got a double I in. Which is a double I?
It's got a double letter in here, and it's 5 letters long. So you're using word structure to figure out what's going on here. So you've got some literacy options there. So double letters are some clues you might look for. Short words, maybe. Some of you might have started looking at 2-letter words and 3-letter words. The and maybe. Of, it, be, to, is. The 2-letter ones. The sentence structure, once you get a bit further through, you think, what would make sense here? We got a full stop. Can you have an and after a full stop? Does that make sense? So, some ideas for using code breaking in your lessons. A variation on hangman, maybe, for keywords and phrases. So instead of having blanks, you have letters substituted in there so that your students can see the structure of the word and they can have a guess of what word it might be. Include punctuation. Gives you a few more clues, makes them think about how sentences are structured, how the words fit together, and how the meaning comes about. Bletchley Park's code breakers obviously used these clues to help decipher codes in the Second World War, and those ciphers and messages that were sent were obviously in German, so there's an MFL link here as well that you could use. Now, I used to be a maths teacher, so most of the ideas that I come up with are to do with maths, and I've used some of these in my own teaching before I became Bletchley Park's outreach officer. Binary addition and subtraction, you're not going to be doing a lot of that at primary level, I know, but if there's any secondary school teachers here, it might be something you want to have a look at. Probability comes up a lot. In the Enigma machine itself, they'd have a set of 5 rotors to choose from, and you'd have to pick 3. How many different ways are there of doing that? Does anybody know how to work that out? You could use that. You could use permutations or combinations. This could be part of a lesson on that, and it shows you where it's useful. You could do this with students a lot lower down the school. I've done it with some gifted and talented primary school children at a workshop I did a few weeks ago. Basically, not overrunning it too much, you work it out. The first one you pick, you've got 5 options. The second one you pick, however, whichever one you pick first time, you've got 4 left. The third one you pick, whichever one you try, you've got 1 less left. So 5 times 4 times 3 gives you 60 different options. So there's 60 ways of setting up the rotors in the Enigma machine. It's just a way of adding a little bit of context, I think, to what you're learning in class naturally. Other things, more probability. Modular arithmetic, if you get into that at A level maybe. Prime numbers, factors and multiples. Most codes and ciphers that are used today, credit card security and things like that, are based around finding massive prime numbers. So codes and ciphers are relevant to everyday life. Solving and rearranging equations. Most ciphers can be given a mathematical context or an equation to set them up. A simple Caesar shift, for example, could be written down as x plus 3 if it's a Caesar shift of 3. To decipher that, you would use a shift of x minus 3. So you would rearrange equations to find that out. Frequency. Now the next bit I want to look at. Frequency analysis. Here's lots of different mathematical ideas all in one go. That's a message that is enciphered in some way. The letters in this particular message come up with these different frequencies here. So the G comes up 18 times, the H appears 16 times, and so on. So you could create a bar chart. Why would you bother to create a bar chart for this? Well, in the English language, E tends to turn up more often than any other letter. So if G is turning up a lot in this message, you might think that you could swap the two over and start to decipher the message that way. So I've swapped in there all the G's for E's. And again, the next most frequent one, the H might be hiding a T, so you could swap those over. And the next most frequent one might be hiding an A. Now, once you get to this point, you might start to spot some clues, which you can then start to bring in a literacy element to your maths lesson maybe. Down here, this word here screams out to me. You've got 3 letters, an apostrophe, 2 letters, an E at the end and an O in the middle. What might it be? You. Might be your. Okay, and you could use things like that. You've already compared 2 bar charts, so you're comparing 2 charts or tables or graphs, and you can go through and use common sense, general problem solving skills to crack the code. So it can quite often be the case that E is the most common letter in a text, followed by T, A and O. This can help when you're trying to decode messages. Aardvark. I didn't have quite enough A's. But this is an important point. I think I'm going to finish on this one because the buzz is about to go. Can anyone see what's up with that? Anyone want to call it out?
Sorry, no E's.
No E's. There are no E's, so that would fool your frequency analysis and you'd have to think about what you're doing again. Okay, that's me done. My details are on the back of this sheet I've given you. If you do anything with codes and ciphers in your lessons, I would really love to hear about it and share it out and tweet it from B Parkhead. Thank you very much.